Have a problem on work and then energy principle. This is problem number 2. 50 lb bucket C is released from rest. Okay, that's important that it says kinetic energy at point 1 is 0. Determine its velocity after it has fallen a distance of 10 feet. So it falls a distance of 10 feet. What is its velocity? The windlass A has a 30, this point A as 30, so you can consider as a 30 pounds cylinder. This one is for I value. While the spokes, you can see we have 1, 2, 3, 4 spokes, and then cylinder rods, again it is for the I value. Each has a weight of 2 lb. Then neglect the pulley's weight. Okay. Let's start to find the velocity. So with our famous formula, it will be that T1 plus U1 to 2, that will be T2. Or you can say kinetic energy at 1 is U1 to 2, kinetic energy at 2. So the question says at point 1, T1 is 0, kinetic energy is 0, because it is at rest. Then we need to find the work. So let's identify forces first. And to see which forces do we have that acts with some work. So firstly, the bucket, it has some weight of the W. Okay. And then we have the pulley, that this pulley is fixed. And since it's fixed, it has a reaction force of R of X. And it has a reaction force of R of Y. Okay. And then the wheel has some weight W. It has a weight of W. And it has also friction forces. The reaction forces R of X, and then the reaction force of R of Y. Okay. That is, let me just show R of Y different place. R of Y. Okay, so these are the 5 different forces acting on the body. The reaction forces, weight of the wheel and the spokes, the reaction forces of the pulley, and then weight of the bucket. So we know that the work is the force times displacement. We have R of X, we have R of Y. This is for pulley. We have R of X, R of Y, and then W, weight of the wheel. Okay, these 5 forces, they don't perform work. The reason is that displacement, this term is 0. You can see fixed and then fixed. So they don't move. As they don't move, they cannot create any work. The only work is created by this W, which is the weight of the bucket. Okay, so let's start with the bucket case then. So we have a bucket, then it will fall. I hope it looks like a bucket. So it has a center G, and then it will displace A. So that will be 10 feet. The bucket has some weight of W. Okay. And then W and then displacement, they are same direction. Okay. Therefore the work is greater than 0. Okay, then the work due to W will be W times the distance, which is 10. That will be, W is 50 lb times 10, which is 500 lb feet. Okay, that is this part of the equation. Now comes the second part, which is kinetic energy. The kinetic energy at point 2 will be kinetic energy of the bucket plus the kinetic energy of the wheel. Okay, so let's start one by one. The bucket, it only translates. Okay, it only translates in vertical direction. So it means that it will have 1/2 mvg squared. The wheel, see, we will take the wheel as here. It has spoke, there's another spoke, there's another spoke, and it has another spoke. It has point G. Okay, and then this one rotates this way. Okay, and the wheel is fixed. Therefore, only rotation. Okay, velocity of G is equal to 0. So that will be 1/2 Ig omega squared. This will be the wheel, and this will be the bucket. Okay, so let's write all equations together. So we have the work part, which is 500 due to bucket only. We have the kinetic energy, which is the bucket and this wheel. So it will be that 500 will be 1/2 mv g squared of bucket plus 1/2 ig omega squared, which is the wheel. And then bucket has a mass of 50 lb by 32.2. Vg is unknown. Ig of this one we can easily find from the table here. Omega is unknown. So we have one equation but two unknowns. So we need one more equation to eliminate this unknown. So I will talk about this one in the next recording.